Hello there. Doing another short video. This is a PhET simulation called Faraday's Electromagnetic Lab. And this duplicates some of what we have in person. What I have in person is a coil and meter setup that operates via the overhead projector. It's very old school, and I'd recommend this to you as well, except it's not friendly on all computers, so I'm just sort of doing it as a demo. Now, this app has a couple of features on it. You can see here we have a magnet, and there's a compass. These are little compasses here that are surrounding it. So you can see the magnet has a north pole and a south pole. We can bring the larger compass near it and see what happens there. What are called the magnetic field lines sort of follow the lines of these mini compasses all around. And where the field lines are the most concentrated is where the magnetic field is the strongest, which happens to be around the poles of the magnet. You can even see magnetic field lines inside the magnet. If I turn this on, you can see there are lines that go right down the center of it. Right. The more interesting things, well, there are two things that I demonstrate using the equipment in the lab typically. The first is an electromagnet, and what we have here is a coil of wire, and you hook a battery up to it. Now, to do this live in the lab, you would wrap a coil of wire around something like a metal nail. That actually helps the effect work better. So you coil it around the nail, you plug it into the battery, and you discover that you can actually pick up paper clips with it. In this vision, or this view of the applet, you can see that the coils of wire, even though there's no bar magnet there, acts like it's a magnet. And if I flip the voltage, it goes the other way, and if I turn the battery off, you have no magnetic field at all. It's by far the strongest through these coils of wire, though. So, there's an electromagnet. Now, it turns out also that electric current in the presence of a magnetic field will feel a force, and that is how your basic speaker operation works. The voice coil inside the speaker connected to basically connected to the speaker cone responds to changing electric signals with a back and forth force that follows the same pattern. Now, the one that looks the most like our overhead projector demo is this. So you have coils of wire and a magnet, and on top here, this is a voltage meter, but easily could be a current galvanometer also, since voltage and current are related. The galvanometer is just an analog current meter, but the point is we can observe signals here, and this was the big sort of mind-blowing connection that Faraday formalized, that you can get an electric signal by simply manipulating a magnet near a couple of coils, and you can see the things that we have control over, and you can watch as I move the magnet in and out. This is the kind of thing I could do on the overhead. So as I move this magnet in, I got one voltage direction, and I move it out, I got a plus voltage. Move it in, it's negative, move it out, positive. You might ask the things that we could control. Now it's possible I could just make the magnet weaker, and if I make the magnet weaker, then shaking it in and out, of course, makes the voltage signal we get a little bit less. If I make the magnet as strong as it can go, get pretty big signals there. Something else to notice, if I just insert it in there, if I just insert the magnet in there, you get nothing. No matter how strong the magnet is. It's just when you insert the magnet or you pull it out is where you get the voltage signals one way or the other. So that's an important thing to notice. It's not about how strong the magnetic field is inside the coils, it's how fast that magnetic field is changing. And the other thing, so I could change the magnet, I could also change the number of coils. So if I change the number of coils and move the magnet in and out really quickly, you see I get spikes in voltage that can go all the way to the extremes.